So what is the magnetic effects of electric current? See, the substances which attract another objects, another magnets, another materials we can say. So those are called magnetic materials. So it will attract those substances. So the property of the object which influence the other materials, like magnetic materials or other materials which can influence. So that property, so the object itself, it has a property that is called magnetic property. Okay, so natural magnet is magnetite. So the natural magnet is magnetite. Okay, so if you suspend the magnet, always it shows north and south direction. At the same time, north pole will repel, south pole will attract. North pole will repel. South pole will attract. North pole will attract. South pole will repel. Okay, so this is about magnetic effects. And if you suspend any magnet freely, automatically it will shows the direction of north and south. Clear. And next one is magnetic field. So the field, see, if you are taking I said natural magnet is magnetite. There are many magnets, those are made by the humans, those are called man-made magnets. The are artificial magnets also we can say. So man-made magnets or artificial magnets. So best example, bar magnet, horseshoe magnet, dumbbell shaped magnet, like a spear magnet, like the different types are there. So U-shaped magnet, like the different kinds, different types are there. Okay, those are called artificial magnets or man-made magnets also we can say. So next one is, so we can take next one is magnetic field. So what is the magnetic field? So I am taking this north pole and south pole. So I am considering this the north pole and south pole. This is the north and south. Okay, the region around the magnet. So the region around the magnet in which magnetic force exerts. In which magnetic force exerts. So if I am taking this north and south, so around this area, if you consider the magnetic field exerts, so that is called magnetic field. The region in which, or the region around the magnet in which magnetic force exerts. So I am taking here, you can see, so I am taking this north pole and south pole around it. So the field in the field will experience the force. So this is the region. So you can see the region around it, the region around the magnet in which the magnetic force exerts. The magnetic force exerts, it is called magnetic field. So here the magnetic field also certain range only it will be. So it is not too much. So it is certain range. So here I am taking this range. So I am considering this range. So within this limit, the magnet which exerts the other force, the magnet which attract the magnetic materials, okay, then we can say that is a magnetic field. So here it won't attract, here it won't attract, here it won't attract. So within this region only the magnet will exert the force, the magnet which exerts a force, that is called magnetic field, that is called magnet. So up to a certain range only, it's not so if I place the object here, if I place the object, so the magnet does not attract. So only certain range, the region around the magnet in which magnetic force exerts, that is called magnetic field. Magnetic field. How the magnetic field will be? So hi dear students, so please do like, share and no share to your friends also this live class. Automatically they will also get to know, they will also join to the live class. So here you can observe in this okay, magnet you can observe. So this is north and south. This is the north and south. So around this region only the magnetic field will be there. Around this region only the magnetic field will be there, right? Yes. So now here if you are taking how the magnetic field will be there, how the magnetic field will be there. If you like this content, please do a like, right? So please do like. So I will feel happy and we can go with the more explanation. So here within this region, I said magnetic field will be there. How the magnetic field will be? The magnetic field will be in the form of field lines. The magnetic field will be in the form of field lines. So I'm considering here. So I'm taking like this. So this is north and this is south. So the magnetic field from the magnets around it. So it will be like this. So outside. So in the form of magnetic field lines. In the form of magnetic field lines. So how the field lines outside of the bar magnet north to south. Inside of the bar magnet is south to north. So you can see outside of the bar magnet is the field lines will be north to south. Inside of the bar magnet is the field lines will be south to north. Okay. So that is about magnetic field. So here I can consider like this. I'm taking this magnet. So I'm considering this a magnet. Okay. So this is north and this is south. This is north and this is south. So outside of the bar magnet, you can consider this outside of the bar magnet. I'm taking like this. So here, so north to south like this. So outside of the bar magnet is you can consider. So north to south, outside if you take outside of that. Whereas inside you can see inside is south to north. Inside will be south to north. If you place the compass over it, if you place a compass over it, automatically the magnetic field, the direction automatically outside will be shown north to south. Inside exactly if you place on the magnet, so it shows south to north. So that is the field lines. So the field lines will be okay. So always as I said, north to south and south to north, outside and inside. Okay. So here the properties we have to discuss. So properties of the magnetic field line. So these magnetic field lines never intersect. So whatever I am drawing this magnetic field never intersect. It won't intersect. It won't intersect. See here, if you are taking like this and like this also, these field lines never intersect. These field lines never intersect. So these are closed loops. These are closed loops. Field lines never intersect. These are closed loops. So from north to south, it will be around it. So south to north also we are considering. Okay. So field lines never intersect. These are closed loops. Outside of the bar magnet is north to south. Inside of the bar magnet is south to north. So that is about magnetic field lines. And few more we will discuss about. And see property, attractive property and triple property. So if you take north and south will repel, south and north, north and north will repel, south and south will repel, north and south will attract, south and north will attract, right? Yes. And if you suspend the magnet freely, always it shows north and south direction. And the next one now, Oersted experiment. Oersted experiment. What happens? So current is passing through the wire. So here, if you are taking the current is passing through the wire. Okay. So I'm considering this wire. So wire I'm taking this wire. Okay. Current is passing like this. Current is passing. So if you place compass here, if you place compass over here, what happens? Suddenly the compass shows deflection. So current carrying conductor exhibit magnetic property. Current carrying conductor exhibit magnetic property. So that is the reason. So the magnetic compass shows the deflection. Magnetic compass shows the deflection. So I'm taking this wire. I'm taking this wire. So wire like this. Okay. So that is showing the deflection. That is the reason. Oersted experiment means a current carrying conductor near to current carrying conductor. If you place the compass, it shows the deflection. It shows the deflection. That is the Oersted experiment. And one more thing, so very sensitive point. So if you are taking the current carrying conductor, I am taking this the current carrying conductor like this. Okay, this is the current carrying conductor. So current is passing upward direction. Current is passing upward direction. So how the magnetic field will be? So just now we discussed the current carrying conductor exhibit magnetic property. So if you are taking this current carrying conductor, in which direction the magnetic field will be? So to identify the current carrying magnetic field of around the current carrying conductor, we are using right hand thumb rule. We are using right hand thumb rule. So along the current carrying direction, so we are placing the thumb. We are placing the thumb like this. So we are placing the thumb. So the curly fingers, folding finger shows the magnetic field direction. Folding finger shows the magnetic field direction. So that is about right hand thumb rule. Okay, so if you like this content, do like, share and subscribe to Student in the Brand. This is Eva Siva sir. So thank you.